Hybrid Cloud Show, episode 26. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So Shane, I thought you could take us out the gate today because I believe you've been playing around with your homelab, and I thought I may as well ask you about it on here.
Well, yeah, I mean, playing around is one way. Building it from scratch is actually what I've been doing. Over the last while in my job, I work fairly regularly on building Kubernetes operators. And we talk a lot about like the design decisions we want to make about what information we might surface to our potential customers. And one of the things I felt as I was working there is that I don't have a lot of customer empathy in that I kind of still don't really like have like a fully fledged Kubernetes environment that I can like properly muck around in and experiment with. We've got one at work, which is like a long running environment for testing, but I can't really play around and experiment with that. So yeah, thought I'd start something myself. There was also this guy on YouTube called Misha who basically promised that if I learned Kubernetes, I'd get lots of fast cars and loads of money, particularly if I signed up to his course. But his YouTube videos have some really nice like demos of his homelab, and it just looks really cool. And I was like, I want to try that.
I'm not sure building a Kubernetes cluster is the easiest route to customer empathy, but I'm willing to go along the ride with you, particularly if there's fast cars involved. So what have you got set up so far?
So to start with, I needed some data storage, and I decided I set some interesting constrictions for myself. One was I wasn't going to spend any money, which is great. I've been getting quite creative with data storage in particular, and I think there's going to be some probably reactions to some of what I've done. So I started by installing Open Media Vault on an old ThinkPad and then just plugging a couple of USB drives in there and trying to set up a NAS from that using RAID 5 storage. Open Media Vault doesn't allow you to create RAIDs using USB. It literally says in big red, this is too unreliable. So I said, screw that. And I did it all from the terminal, which was quite easy. So I've got my RAID 5 storage now, and I am now serving that out as an NFS drive for my Kubernetes cluster to make use of.
Is Open Media Vault based on, it's a Debian-based kind of setup, isn't it?
Yeah, it's Debian with a web UI. I'm not using any of that now because my system is too ghetto.
So why did you go for Open Media Vault at all to do the storage?
Well, I thought it'd be like easier to administer afterwards, and I really haven't really set up many RAID servers by myself, so I was like, this might be easier. It's actually really easy, even without Open Media Vault. I would probably, if I was doing it again, just use Debian from scratch and just set it up myself. It's pretty quick and painless.
But hang on, you've listened to shows on this network for long enough. So why are you just not using ZFS or running it on TrueNAS or something vaguely sensible?
I don't know.
I'll channel my inner Jim.
Nah, just cobble it together with a couple of shell scripts. It's much better. That's just how it works. What I'm going to do is once I've actually proven this thing has legs, is I'll probably invest in a Synology or some other boring proper NAS and buy some drives. But at the moment, I just need to prove. Once I'm staying up at night worried about all my critical data on this crappy NAS, then I'll buy something.
I feel like you should buy something before you move critical data.
Yeah, no, I know. You do think that, but I may never need it or use it. So, this is my motivator to actually, put something serious on there.
Okay, so then why NFS versus just having something on disk? Like, do you have multiple nodes that you want to share persistent volumes across?
Yes, I do. So the first thing I decided to run on this is Unify. And the reason for that is I've already got Unify running on a Docker container on a Raspberry Pi. And as soon as I moved it to this cluster, I could then harvest that Pi to make it a part of the Borg Kubernetes cluster, essentially. So I've got Unify on there. And what I've got is a laptop that's running as the control plane. And then I've got two nodes. One is another laptop, and then another is this Raspberry Pi. And at the moment, Unify is load balanced across both. Traffic's going into the control plane and being routed to the two nodes. So yes, I needed persistent volumes across nodes. It's quite nice. I've got like this NFS provider, I've got automatically issues persistent volume claims. So I don't need to do that when I'm setting everything up. So yeah, I just set stuff up in Kubernetes and it all kind of hangs together.
You're using the NFS external provider?
The Subder something or other. Yeah, that's the one I'm using. So how it's actually hanging together is it's K3S and this is the control plane, and then K3S agents and all the boxes, and then traffic's routing across those. I've got it. I was trying to use Talos OS, or is it just Talos?
Talos, yep.
But it was quite painful, particularly as you can't shell onto it. And I was doing lots of dodgy stuff like trying to network Kubernetes over wireless while I was testing things out, which wasn't so easy with Talos. So it was just handier to run K3S on Debian and shell onto stuff. So, but it's all running using Flux and everything's gone through GitOps. So I also made another rule, which was everything's through GitOps.
Sounds like quite a lot of work to run a Unify controller.
Yeah, this is just a start. I have plans to move Nextcloud on there. It will become my everything box or series of boxes. It's been quite enjoyable to run it like this. Like it is like turning my home servers, which are all like bits of glue and string all strung together, into something where the boxes are now a little more like cattle and not pets.
But it's still hung together with bits of glue and string over a Wi-Fi network accessing NFS.
Over Wi-Fi.
It's not over Wi-Fi. Most of the nodes are not over Wi-Fi.
Most.
Just some of them are because I've run out of ports on my switch.
You're just like writing to MongoDB from the Unify controller over Wi-Fi. This could never be a problem.
Over NFS.
No. Performance has been great. Thankfully, I've not got anything important on there yet. But it's been kind of enjoyable, like being disciplined, which I rarely am. Usually if I'm like setting up a box, like I might be like, I'll use Ansible for this. I'll make it all automated. And then after a while, the standards start to slip and you're like, screw it. I'm just going to apt install or edit this file. And then all your IAC is trash. With this sort of solution, what's been quite nice is I can just create a folder which like represents an app, we'll say, and then kind of copy paste pretty much everything that I need for my next app. So like my Unify app, I'll copy paste that and make a Nextcloud one, change some configuration, like what the Helm chart is I'm pulling down and how much storage I need and the ingress DNS name. And then it's kind of in theory good to go. I'm having a lot of pain with that NAS, as you might expect. Lots of permissions problems, but generally, though, it is a bit of copy-paste and some tweaking, which is nice.
So I'm going to wind back a bit like I would if I was talking to somebody real and ask, are you doing this just for kicks, or is there a reason you want to have a multi-node set up for this stuff?
Again, it's probably a little for that customer empathy thing. Our customers are enterprise customers, and a lot of them are running massive, quite complex K8s clusters. And at some point, like my aim is to get this thing to be like publicly available, which terrifies me. So I need to like get my head around Kubernetes security better. Right now, everything's just got access to everything because I'll solve that problem later. It's all hidden on my private network. But I think it's forcing function for me to learn more and more about the ecosystem, how you kind of do things in K8s and how you like operate and maintain it over time.
Yeah, right. So you're doing this because you want to understand the chaos of an enterprise deployment as opposed to because you want to have 3 laptops running your Unify controller.
Yeah, exactly. At the moment, I'm not really sweating it with the Unify controller. It's a problem. I really need like my Jellyfish server that my kids will melt down about if it goes down. Then I'll start to really get serious about monitoring and uptime and everything. But right now, it's just a bit too easy.
I mean, it sounds to me like your Jellyfin server has got a much lower likely uptime with this setup than it would if you made things a lot simpler.
Maybe. We'll see. Probably.
Imagine that. Transcoding on that Raspberry Pi. Go ham.
It's just a Wise box right now. It does fine.
I say, that pod spinning up on the Raspberry Pi is a great opportunity to go and learn about taints and stuff and node selectors.
Yes. Yeah, absolutely.
Yeah. Okay, so I want to go back to the storage first, because I think that is a good place to start. So we've got the storage. The way you've done that is you've cobbled together a bunch of stuff from a drawer, plugged it into something in USBs and stuck something on it and RAIDed them together.
Super safe. Let me ask you a question. Why not just do local disk and just have each workload run on like a specific node, and then that way it always has access to its local disk? That would be a safer way to kind of start up before you scale out to high availability.
So what you're suggesting is like I'd have one node with a set of storage, like a drive, and then have only the apps that access that drive using it essentially locally.
Yeah, just a folder. You don't even have to give it a whole drive, a whole disk. You can just give it a folder. And that makes it a little more reliable than just NFS on Open Media Vault. Because that's how I started first. And then eventually I scaled up and tried like Ceph. And then I eventually landed on Longhorn, which I'm not sure I recommend any of those, but tackling storage is a very tough part of Kubernetes, especially a private cloud Kubernetes. So I wanted to get your feedback on that.
That's a great suggestion. Kind of didn't even think about it. I think my brain is so cloudified. It's like storage is just this separate problem. I never even thought to like connect things to a direct server. Maybe I'll do that. Probably I should do that. Now's the time to do that. I probably won't, but it's a really good idea. I guess it's nice, the idea of like these boxes might be unreliable and go down. So it would be kind of cool to be able to kill one and then bring something up. But if I'm iterating towards a better solution, maybe I could. There's definitely some use cases. Like, for example, the stuff I'm serving from my Jellyfin server right now is like many terabytes of stuff. And I don't particularly want to have that rated up because I don't really care if I lose it, really. So I could plug those all into a box and just have a node running Jellyfin right now. So that's, yeah, I may steal that idea. It's a good shout. So no, I've got no reason to defend this.
Yeah, I was interested you'd separated the storage out. Recently, I've seen a number of people playing with things like microcloud and stuff where they hyperconverge it all, and you've got the storage is on the same thing as one of the Kubernetes nodes, and then effectively it's a combination of LXD, microcates, and Ceph under the hood. So and micro oven. So you've got this combination of different technologies that solve different parts of the problem, but they're effectively all the same stack on each of those nodes, as far as I understand it, connected together. So interested that you split out the storage.
Yeah, it just felt like I'll just solve storage and then I will solve the Kubernetes bit. I don't know. It was just the way I broke down the problem more so than it being an ideal solution, probably.
Yeah, I mean, I can imagine doing it myself just because I've got the ZFS server sitting there already with NFS mounts. So I can kind of see the attraction of plugging that into a new thing that you were building on top of it.
And storage isn't easy. If you're doing Ceph, then you have to assign like a whole disk to it. And if you're just playing with like, a laptop with one drive, right, you can't assign a whole disk to it. That's why I started off with Longhorn instead, because I could just give it a piece of a disk or set quotas.
I don't know Longhorn. Can you give me a brief couple of sentences on it?
Sure. Longhorn is the distributed storage that's part of CNCF that was from Rancher. And that's where I eventually found it first. And long story short, it basically does persistent volume and persistent volume claims over NFS, but in a really nice, very easy to use native way. I think it's one of like 2 or 3 that are actually like adopted into the CNCF. I really like it. And they've been fairly responsive too. I've had issues where like I've had like persistent volume just keep detaching or not detaching at all and just being stuck on a node. And I've reached out to them, submitted a issue, and they've helped me fix it. It's gone well so far.
Sorry, stupid question. Why is this better than just using that NFS external sub-dir provider thing?
Because it's hyper-converged, meaning that the nodes that I'm running my Kubernetes servers on, right, all my different nodes, both master and workers, are my storage backend. And so what it'll do is it'll have volume. You specify, I need 20 gigabytes or whatever, and then it'll replicate that however many times you tell it over however many nodes. And that way it's all hyper-converged, all running on the same nodes.
Okay, that's cool. I get that. I like that. I may steal that as well when I get when I start panicking about this NAS a bit more.
There's a bit overhead, and what I've eventually done have just said to only run on worker nodes. So if I have 3 agents and 3 control planes, I just say run the agents and leave it at that. And that's actually been very reliable. They do recommend 10 gig networking, but I've been using 1 gig for 3-4 years now. It's been totally fine.
This episode is sponsored by SysCloud. Companies big and small rely a lot on SaaS applications to run their business. But what happens when critical SaaS data is lost due to human errors, accidental deletions, or ransomware attacks? That's where SysCloud comes in. It's a single pane of glass to back up all critical SaaS applications such as Microsoft 365, Google Workspace, Salesforce, Slack, HubSpot, QuickBooks Online, to name a few. SysCloud also helps with ransomware recovery, identifies compliance gaps in your SaaS data, monitors for unusual data activity, and can automatically archive inactive SaaS data to save on storage costs. Plus, it's SOC 2 certified, so data remains secure in the cloud. Over 2,000 IT admins already trust SysCloud to protect their SaaS data. Head to syscloud.com for a 30-day free trial. And, for a limited time, use code HCS to get 50% off your first purchase. That's syscloud.com. Okay, so you've got your storage, and you've got your Unify. That's an interesting kind of segue into what are you going to do about networking?
There's a couple of different challenges there. Networking between the control plane and the node is fine. That's pretty trivial. I've got everything basically on the same switch over Ethernet, so like connectivity's fine. I think the interesting networking issue I've got is it's to do with ingress and traffic. So traffic load balances across all nodes and the control plane. So in terms of like connecting to a particular endpoint, I can point to, as far as I can tell, any of those IPs and I'll get routed to my Unify controller. What's interesting is that I've just got Tailscale running on the control plane. So right now I go to Unify, my Tailscale name. It then hits the control plane. Traffic will then interpret that and then route it to the service, the Unify service. But I'm not benefiting from any of the load balancing that traffic provides because I've just got one IP serving everything out. So it's not getting the benefit of this load balancing. So I wondered, how does one even solve that? Like, I have no idea. At the moment, I'm just doing something ghetto, which is just the theme for this whole thing.
Are you using Tailscale as like installed in Kubernetes or on the nodes themselves?
I don't even have it on the nodes. I just have it on the control plane right now. And it's running as like a separate service just on the box itself.
So yeah, you're completely bypassing the ingress layer of Kubernetes. And that's your issue here. And because Traefik is an ingress controller, that's the issue here. That's why you're not getting the load balancing. What I'd recommend you do is one of two things. Either A, go all in on Tailscale, install the operator, and start using it natively. Cool, done. The option two is to use something like MetalLB to be able to provision yourself a static IP as a load balancer service type. And then from there, you can reference that whenever you want to come in through ingress. So let me give you an example. Right now you have Traefik as load balance across all of them, right? Cool. You provision a load balancer service, and then you tell Traefik, hey, anything that comes in on this IP route, you're going to route somewhere else. And then from there, it just goes straight to whatever service you pointed at. And that's a very cloud native way of doing it. That's how most people do it, where you deploy an ingress controller like Nginx or Traefik or something like that. And they all get a static IP. Usually it comes from a cloud load balancer. But in this case, MetalLB is an on-prem load balancer that'll give you a static IP out of a pool that you specify. And then from there, whenever you hit that IP, you tell Traefik, listen to this, and then it'll route traffic in as normal.
So what I'm doing right now is I have ingress routes in Traefik, and they are routing to the services. So I am using Traefik. What you're saying is, would this give me load balancing across the Traefik instances?
No, it would give you a single IP to hit. The difference is that it gives you a single IP that you can address from anywhere, whether it's internal, external to your network, and then get into your different services versus having to hit each individual IP of your nodes.
But I'm not having to hit the individual IPs. I've got Tailscale. I hit Traefik. Traefik routes me to the node already. It's just the issue is that Traefik's load balanced across all my nodes. So I've got all these external IPs. I've got all these Traefik instances all load balanced, like it's in there. There's loads of them running.
Right.
But I'm only using the one that's on the control plane. Instead of that, could I just get rid of all the Traefik instances on all the nodes, just use the control plane as a single point of failure and then hit that IP? Or is there something cleverer? Or is what you're describing, would that solve it? I'm confused.
So what Sean is describing would solve your problem. So this gives you a single IP to hit, which load balances the traffic going into Traefik.
Ah.
That's really complicated to say. So if you've got traffic running on 3 worker nodes in your Kubernetes cluster, this will give you a single IP address load balanced across those 3 nodes that are running traffic. You hit that IP and it handles which one of those 3 worker nodes that it will end up hitting. So the way that I used to do this, and this was OpenShift's very opinionated way of running Ingress, was that I had 3 nodes across 3 availability zones that were tainted to be router nodes. And they were the nodes in my cluster that ran my Ingress. For me, it was the HA proxy Ingress controller. For you, it would be Traffic. Then you're using MetalLB to have a single addressable IP for those 3 router nodes. In my case, I was using an ALB or an NLB, I can't remember which it was, sitting in front of those in AWS to give me that single IP. So what MetalLB does is gives you a load balancer sitting in front of traffic, which is then handling your ingress into your cluster. That could be a single IP pointing at your 5 master nodes and your 8 worker nodes. It could be a single IP pointing at 3 nodes tainted as routers. It could be any one of those things, but you just basically have that MetalLB pointing at whatever nodes are running your ingress controller.
Gotcha. Okay. That sounds like it solves my problem. Thank you both.
Yes. And again, it's hyper-converged. It's all together running on the same node. So I like that a lot.
Yeah, this is interesting. It's the same way the NAS and your Longhorn suggestion kind of hurt my brain a bit, in that it's like this distributed but not distributed type model. And that's why sometimes I think I struggle sometimes still to click with, okay, all right. The system handles it all, It's quite cool.
Yeah, I mean, it kind of goes back to that first principle of Kubernetes as just using it as a state machine, right? You're basically saying, this is what I want, this is where I want it, and you don't worry about any of the rest of it.
Yeah.
So I have a question, which is, why is this prod and Shane's playground? Why not just leave the stuff that your kids care about on the Wise box, and then, I don't know, go and buy a couple more Wise boxes and a Synology, or a couple more Wise boxes with some storage in, to run Shane's lab that he's inevitably going to mess up by trying to run some massive deployment to test a work thing on?
I haven't moved it yet, so that's still a pending question, but I would like to have some skin in the game in terms of I learn by feeling pain, basically, I think. We talked about could you do a certificate, or could you self-learn, in a previous episode. For me, it's I need things on fire, and then I'll figure it out and fix it at the time. So I think the more terrified I am of this setup, the better I'll set it up, and it's just terror-induced learning. It's good for me.
Got it. You have a much more forgiving family than I do, because it would take one time of them opening Plex or whatever and it not working, and it would be, right, we're paying for Netflix again.
I'll just blame the kids and say they plugged something out, maybe.
I'm really glad we have this on recording so that we can remind you of this discussion at multiple future points.
You're not there yet, but I highly recommend having, like Gary said, home lab and home prod, because Jellyfin is a critical infrastructure.
There is a reason that my home prod is just a Mac Mini connected to an SMB share.
Few moving parts, right?
Yep.
One thing I actually did that was semi-interesting, and then I completely broke, but it was quite helpful at the start, was I had Kind running on my local machine, and I would just have that slam through all of the Kubernetes config I've got to test changes, and I had a little make file that was doing quite a nice job of that. Again, something's gone awry with it, I don't know what, but any other tips for okay, right, I can have a dev and a prod, but is there anything you folks do locally to make sure you don't mess up your entire home prod equivalent?
Yes, I test in home lab, a separate Kubernetes cluster.
Right.
Can you remind me what Kind does? I think I've come across it where it was rebooting nodes all the time, but what are you using Kind for? Because it sounds like it's something different.
Kind is a local ephemeral Kubernetes installation you can use.
Microcates, K3D, that kind of thing.
Yeah, I see.
So that's actually a great point, Aaron. Why, Shane, did you decide to go with in your own words, glue and duct tape kind of 3-node architecture for this Kubernetes home lab versus just running Microcates or Kind or something on just one machine and testing with that?
I think I wanted to know what it was like to run multiple nodes on bare metal. It's been a really good learning experience, just registering agents with a control plane. it's kind of nice feedback, even like having literally multiple physical boxes all contributing to this cluster. I've found that to be quite rewarding and kind of an enjoyable feedback loop of like, oh, look, it's running over here, running over there. Like, it's more fun than I thought it was going to be, actually. In a weird way, it's kind of like when I first learned Linux. Like, it was confusing and weird, but it was kind of fun, and there was lots of like resources to learn from, and like you can pull from like different locations and get inspiration from it. Like Misha was one example, but like even just pulling from people's Helm charts and figuring out what these things do and tweaking it a bit. Like it's been fun. But yeah, like having the multi-node was just to run a real thing and see it go. And I'm kind of, whilst it's probably completely over-engineered, but also ghetto at the same time, I've been enjoying it so far. I mean, I'll come back in 2 weeks and be like, this was the worst idea ever, and be bringing from a hotel room because my family's kicked me out. But, for now it's good.
So this has turned a little bit into the Beat Up Shane show, but at that point I think we should wrap things up. Before we do, just a quick thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon you can get an ad-free feed of either just this show or all the Late Light Linux family shows, and sometimes you receive episodes early. If you have any questions or feedback, you can send those to us at show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.